Okay, so today then is about interacting with databases from Excel. We'll take a kind of a peek at kind of the built-in tools for doing this, and then we'll also see we'll spend most of our time today working on accessing corporate databases through VBA. So it turns out that today, the vast majority of corporate data is stored in a kind of database called a relational database management system. Oh, you probably have some experience working with relational database management systems. Can you tell me the name of any relational database management system? MySQL is one. Aquadata I'm not familiar with. It might be. What's another one? SQL Server. That's Microsoft. They pronounce it SQL Server, but there's kind of a history there. I'll tell you why it's pronounced that way if you want me to. Oracle, yeah, is the big one. Other one you probably haven't heard so much about, DB3. It's actually the number 2. Microsoft and IBM kind of battle for the number 2 position in this space. Oracle has a comfortable lead in the first space. You said MySQL, which is open source, but also owned by Oracle. PostgreSQL is another one that you may have had exposure to. And there are others. One we haven't mentioned yet is Access. It's kind of the little kid there. It's not really meant for managing corporate data, but might be meant for managing data around a project where you've got 4 or 5 people working together on it and you want to have access to it and so forth. So that's, by the way, the term relational in relational database management system means what? Anyone know what that means? It's like a word we use a lot, and I think most of us don't have any idea what the word means. Go ahead. It totally has tables, and it has primary keys and foreign keys that you use to create relationships between the tables, or between rows in the tables. But the term relational has nothing to do with relationships. It's kind of the thing we think, oh, it means we can make relationships in this data, is relational database management. It turns out a relation is the mathematical word for table. And so what we're saying here is we are saying these are databases that store their data in tables, logically. We use tables. And so that's the kind of data that we're working with. Just really in the past, I guess in about the past 10 years, there's been some real competitors to the relational model. The relational model has been the king of databases since the 1980s. It really started in commercial use in the 1970s, but by the 1980s, it was the king. And it is still the king of maintaining corporate data. But the problem is we now need to give access to data not just to the corporation, but with the internet, now we're trying to give access to lots and lots of people that they're not our employees. And so now instead of having thousands of employees that have to access this data, we might have millions or billions of users that need to access this data, and the relational model typically doesn't scale up that well to those kind of web scale numbers. But still, in terms of how we're accessing the data that we store and use day-to-day operations for corporate use, relational database management is still the king. All right, so let's get a picture kind of how this works. I'm going to come here and we've got a little presentation. This will be fun. So this is how the data are managed in relational database. Kind of the big picture about how we do this. And here is the big data. I love this slide. There's nothing else going to fly in. That's all. This is the slide. Data. So we've got, that's the whole point about the relational database management engine, the software that runs this. Its job is to protect the data. And so we've got data here, and then we've got a piece of software that we call the database engine. So when we say Oracle, Oracle is a corporation. It has lots and lots and lots of software. But if you just say Oracle, you're talking about their database engine. When you say Microsoft SQL Server, it's a database engine. IBM's DB2, it's a database engine. MySQL, database engine. Now when you say Access, Access is more than just the engine. Access has built into it a database engine. And the engine itself, in all cases, the engine is non-visual. It's a service. It's software that kind of sits there and waits for other software to talk about it. We'll see kind of the whole picture here in just a minute. But it is, you don't ever just kind of start interacting with the database engine. It takes a different piece of software to act with the engine. The engine is non-visual. Do you know what the name of the engine is in Access? Now it's called the ACE, ACE, short for Access Engine. Before they had the ACE, it was called the JET engine, J-E-T. which got to be the best example of a three-letter acronym where they came up, this would be a great acronym. Can we possibly think of letters that would go with this acronym? Because this is not just an engine, this is a jet engine that we got here. It actually stood for Joint Engine Technology, JET. Didn't really mean anything except it was called the jet engine. But the point is, everything that you see when you're working with a database is not the engine. The engine is a service, it's non-visual. And the engine then has responsibility for all these things, data security, making sure that only the people that are supposed to have access to the data have access to the data. And this really means two things. Number one, if there's some kind of hacker who's trying to get into the data, who's like trying to bypass everything, it's the engine's responsibility to say, you can't get at the data. And typically they'll do that by encrypting the data. So unless you go through the engine, we're saying no one else can get at the data. But the second thing we say when we mean security is to say we've got lots of sensitive data in here. And data that some people need to have access to, but not everyone gets access to it. And so keeping track of who's allowed to have access to what is also kind of wrapped up in that data security. Data integrity, making sure that the data are meaningful. For example, if I say in one table I've got a list of customers, here's customer number, customer 12, customer number 42, customer 99, I've got all the information about the customers. Over here, I've got a list of my orders. So here's an order that happened on January 1st, and it's for customer number 17. If I put customer number 17 in the order table, there darn well better be a customer 17 in my customer table. That's data integrity, that the data are meaningful. And so that's responsible of the engine. That if if a user try to say, oh, this order belongs to customer 17, and there is no customer 17, the engine should say, no, you can't, you're not allowed to store that. Data recover. Oh, missing a Y there. Data recovery. So if we're right in the middle of writing some data to the disk and we lose power or we're stuck, it's the responsibility of the engine software to be able to say, when it comes back to life, for it to recognize, oh my gosh, I was right in the middle of doing something, it's only halfway done. I mean, can you imagine if you were doing like a transfer from one account to another and you got halfway through, like you took the money out of one account, but you didn't add it to the next account, and things like kind of got cut off right there in the middle. The engine has to be able to come back and realize, oh, wait a minute, we can't, that was part way done. We got to put that back together. So that's data recovery. Data definition, being able to structure the data, data manipulation, putting data into the database, changing the data that's in the database. But the thing that it spends most of its time doing is running queries. We're going to ask a question. Give me a list of all my customers who have purchased a printer in the last 6 months who have not also purchased toner. They bought a printer from us, but they're getting their toner from somewhere else. We want to reach out to these folks. We even know what kind of toner they need. We'll tell them they got a special on their kind of toner. If you would just, let us know. That's the kind of questions that we can ask. And that was the thing that made the relational database management approach so very, very attractive, is we said, listen, just get your data in there, and then you can ask any question you want about the data. If the data's in there, you can ask the question about it. And that's still where relational database management really, really excels. If the data's in there, you can ask the questions out. Before relational database management, we could have all the data that we needed to answer questions in the system, but there was no way to ask the questions. And that's really what this does for us. But remember, everything we've talked about right now is non-visual. There's no way to see it happening. So now, now comes the user. And I realize this movie was made probably way before any of you were born. We're going to watch this part of this from Star Trek IV, The Journey Home, I think is what it's called. Anyway, are you familiar with the premise of this movie? Actually, as you look at these folks, who can name at least one person in this picture, one character in this picture? Yeah, okay, so here's Dr. McCoy. Very good, he's getting old here. That's not this guy. This guy's an Earthling. This guy's actually from they go back in time. This guy's from the 1980s. These guys, of course, are from the future. What century is Star Trek in? I don't know, some future century. Montgomery Scott here. So the premise here is, how long can we spend on this movie? How many of you have seen this movie? There's a few of you. This is just a great movie. It really was a fun movie to watch. But the premise is ridiculous. There's some deep space probe that's coming to Earth, and it's putting some kind of waves that are like destroying everything. Everything is going crazy. It looks like Earth is going to be destroyed. And it seems like this probe's trying to communicate, but no one can figure out what it's saying. Of course, Dr. Spock is able to figure out what it's saying, and he realizes, you guys assume these guys must be trying to talk to humans, but it could be talking to somebody else. And it turns out they're trying to talk to the whales, humpback whales in particular. And the humpback whales aren't responding. And so the probe is coming to find out what it is. And it's unknowingly destroying the Earth, trying to talk to the humpback whales. Well, how come the humpback whales aren't responding? Well, they're extinct. And so it's up to the crew of the Starship Enterprise, which actually, if I recall right, they're now actually on a stolen Klingon bird of prey. Anyway, they've got to go back in time and collect some humpback whales and bring them to the future so they can talk to this probe and save the world. Isn't that a delightful premise? So now they're back in the 1980s, and it's their job now to get some plexiglass to build a tank to be able to take these whales back to the future. Okay, so that's what's going on right here. And I'm going to jump ahead to 1 minute and 56 seconds. Uh-oh. That should do.
Yeah? I noticed you're still working with polymer. Still? What else would I be working with? What else indeed? To put it another way, how thick would a piece of your plexiglass need to be at 60 feet by 10 feet to stand the pressure of 18,000 cubic feet of water? Oh, it's easy. 6 inches. We carry stuff that big in stock. I suppose.
Those of you who have any engineering background realize you can't, there's not enough information there to answer the question because the volume of the water isn't really what's important, but anyway.
Just suppose I were to show you we manufacture a wall that would do the same job, only one. That's something to you. Eh? Here, Joe. Perhaps the professor could use your please.
Ah, we're getting to the computer. That's the whole point here.
Computer? Computer? Ah. Hello, computer. Just use the keyboard. Keyboard? Oh, wait.
We're about to see Montgomery Scott's familiarity with Mac OS 3. It's amazing that he knows this stuff. With about 20 keystrokes, watch what he can do. Okay, maybe 40.
Transparent aluminum?
Transparent aluminum. Okay, so this is all just to get to the point. There has to be some interface between the computer and the user. And so here we now have our user who has to somehow be able to interact with the data in the database. But remember, the user doesn't actually interact with the database engine. So everything the user sees working with the interface has got to be front-end software. And so that's what we call the kind of general term for the database, the part of the database that the user actually works with. We call it front-end application. Now, here's the interesting thing. Well, remember, the engine is responsible for everything protecting the data. Well, the front end is responsible for everything about how that data is displayed to the user. Displaying the data, formatting data, aligning, in some cases sorting the data, but the whole point is its interaction with the user. The neat thing here is that we can mix and match front ends and engines. It's not like we have to have one program that's written all the way through. We can say, oh, we've got different front-end software that can work with this engine, or we've got different engines that can work with a particular front end. And so the way it works is that the front end then interacts with the user, gets all the information that, or finds out what information the user wants. We send, that front-end software sends a request to the engine. The engine then has direct access to the data, and it processes that request, whatever it is, and then sends some response back to the user. In relational database management, what we have here then is the typical language here is structured query language. And it's usually augmented with some other stuff that's specific to the engine itself. Structured query language is the default language for manipulating data in relational database management systems. So it might send the request or figure out that the user wants to see that list of customers that's purchased a printer in the last 6 months. The front end presents that question to the user in some way that they might understand it. The user doesn't have to type out the structured query language. The front end can say, "Oh, what do you want to? What do you want to see?" Could have some kind of general query interface. "Oh, I want to see customers." Great. Well, how do you want to see them? Well, those that have purchased something, and it can kind of do that graphically, and then ultimately produce the request the way the engine needs it. The engine then processes it and then sends back the data the user's after, or sends back an error and says, "Sorry, what you asked I couldn't do for whatever reason." Or if what they're asking it to do is, instead of like retrieving data, trying to put data in, it might just send a message back that says, "We're successful. Right? You wanted me to record this information. Great, I've recorded it." Now, what we're about to do today then is we're going to use Microsoft Excel as the front end for Microsoft SQL Server backend. So we've got some data here that we're going to access, and that's the approach here. And we could use Excel for a variety of different backends. We could connect up to Oracle here. Why do we use Microsoft SQL Server instead of Oracle? Well, actually, they're both. I mean, in both cases, we have to actually have the server up and running somewhere. And I've got Oracle servers and Microsoft SQL Server just kind of sitting there ready to be used. But the problem here is that if I want to talk to Oracle from Excel, I have to have the Oracle driver installed on my machine. If I want to talk to SQL Server from Excel, I have to have the SQL Server installed on my machine, but it comes with Windows. And so it's already installed. We don't have to go through that step of installing the driver that says, what's the glue that gets these two to connect to each other? That's already installed for SQL Server. But we could do this with any database management system, but realize there may be a separate step involved of getting, it's called the driver that lets us make the connection between the two. Okay, questions on the approach? And in fact, what you're seeing here is called the database approach. This is the way that we manage database. There's the data, there's the engine, and then there's the front-end software. Where we plug the network into this makes a big difference in terms of performance. The network could go between the user and the front end, virtually. It can go between the front end and the back end, or the engine, which is the best place to do it. You can even put the network between the engine and the data, which really makes performance, it's really a challenge if you do that, but it can go there as well. Okay, so let's take a look at Excel, how we might do this in Excel. So I'm just going to make a blank file in Excel. File, new file. Oh, even before we do this, I've given you a link, a web link on Learning Suite. So to data.websql.org. And the username here is VBA student. And the password, if I can get back to where I was. The password is here. These are the times that try men's souls. That is the password. More of a passphrase, really. Long enough that you probably want to copy it instead of trying to type it. But then, and this is a really simple, so now what I have here in this web browser is front-end software. It's collecting some information from the user and it's going to send it along to the database. It's really, really simple. It's just asking for the structured query language statement to be sent along to the engine. It doesn't really do very much, and it formats the results for me to be able to read them nicely. But let me go ahead and now do a structured query language statement. Select star from Red Cat, which is the name of a fictitious shoe company, dot manufacturer. I'll say submit. We'll send the request to the engine. The engine will send the results back to the front end, and the front end displays it here for me to be able to see it. So we've got, 50 some odd manufacturers here, and here's the information about them. And so to be able to work with Excel, well, to be able to work with VBA and corporate database repositories, relational repositories, we need to know something about structured query language. How many of you have some experience with structured query language so far? Looks like maybe a little, right about half. It turns out the stuff that we're going to do is not going to be that involved. Structured query language can be crazy, but it can also be very simple in the simple use. And the stuff we're going to be doing is going to be very simple. Let's now kind of see how to accomplish what we just saw here through Excel, not with VBA, just through the Excel interface. Now, it turns out this next part, we can handle kind of a few simultaneous connections on this server. It's not a really high-end server that we're connecting onto. So I'm going to ask you to this next part of the example, just watch me do it. And then if you want to do it later on your own, you can kind of go back to the video and kind of follow the steps and do it. But if we all try to do it here in class, I think it'll be a bad experience for everyone. So, and one more kind of little word of warning here is that you cannot, what I'm about to do, you cannot do on the guest network. You have to be authenticated, so you have to be on EduRoam, or in fact, everything that we're going to do connecting to this database, you have to be on an authenticated network. So if you're on the guest network now, why don't you go ahead and get yourselves connected onto EduRoam if you can. If not, you'll just be watching everything we do today instead of participating. And it's probably worth a little minute to understand why that is. When you talk to any kind of server using an internet protocol, when I say internet protocol, you're familiar with the term IP address? Oh, what's your IP address? The IP stands for internet protocol. It's so when I'm working with an internet server, it's not enough just to know the host that I'm working with, like the name of the server. In fact, it always takes two things to communicate with a server. Let me just go to byu.edu. So this is the way that we're used to thinking about hosts, is with a host name. And so because I'm dropping this host name into the browser, it's going to try to communicate with that host using a web protocol, but specifically, it's going to try to use it on a specific port. Now, first it has to do is it has to translate the name. It has to do a name lookup. It's got to say byu.edu, what's that? And it's got to do the translation of the address. Your browser does that without you ever seeing it. But the second thing it does, it has to know which port to talk to that server on. So that's the part that I'm thinking maybe new. How many of you say, oh yeah, internet ports, I totally got it. I know internet ports. A couple of you. Okay, so when you have the host name, that gets you to the machine. But there could be lots of services running on that machine. That machine could have a web server. It could have a mail server. It could have a database server. What other kind of server could it have on it? It could have an FTP server. There could be lots of different services that, in fact, it could have 3 or 4 different web servers, are all kind of running and handling different things there. And so you have to have a way to say, out of all the services that could be available on this machine, which one do I want? And the answer is, how do you do that? The answer is you use the port. You tell it which port you're using. And so when I talk to byu.edu, if I don't tell it which port I'm interested in, it's going to go, you must mean port 80. Port 80 is the default port for web traffic. So watch this. I'm going to come right here after the host name, and I'm going to put :80. And now I'm telling it, talk to this host, but specifically on port 80. Watch what happens. It goes, great. Yeah, I'm totally talking to BYU on port 80. In fact, it's gone to HTTPS, which is a different default port. This is a secure protocol. And so I think that's, maybe someone can help me with this. I think it's 443. Is that right for HTTPS? Anyone know? Well, I'll plug a 443 on here since we're doing HTTPS here. And yeah, no problem. But what if I put on here, let me copy this, go somewhere else. I'm going to put this back, and I'm going to put on port 444. I'm telling you, go to that same server, but try to communicate with a service on port 444. The browser now is, you can see it's kind of spinning here. It has sent the request off to that machine, and it has said, I'm making a request on port 444. And now the browser is waiting for the web server to respond. Well, the web server is not going to respond. Why not? It's not listening on that port. There's a web server at byu.edu on that machine, waiting to respond, waiting for requests, but it's expecting requests on where? Port 443 or port 80. It's not listening on port 444. And so the browser goes, great, you want to talk on port 1444? It sends the request. That request gets routed, and the browser now is waiting patiently for that server to respond. it doesn't know there's no server on there. The only way it's going to know is it's eventually going to go, I've been waiting too long. There must not be a response coming. And it will wait for quite a while. We'll come back here in a minute. We'll see that it's declined. And so the point is that if you're on like the guest network here, we say, listen, we got internet. We know your life. We know you need internet for your life. It's tough to live without internet. And so you come onto campus, even though you're not one of us, you're just visiting. We're going to give you guest access. And we're going to allow you to do stuff on port 80 and port 443 and the normal ports that we think you can't live without. But we're not going to let you communicate with a database server. SQL Server, by default, will listen on port 1433. And the guest network, when you make a request on the network for something on port 1433, guess what the guest network does? It looks at that request and goes 1443, so interesting, and it throws it in the trash. It just doesn't route it. It's our way of saying, we don't say it explicitly, but we're saying, listen, you want to talk on port 1433, get yourself authenticated. You can live without SQL Server. You might not be able to live without your email, so we're going to let you go to a website, but you can live without SQL Server at least until you get authenticated. And so all the stuff we're doing here, you have to be authenticated because we're working with a route, or we're working with a port that doesn't get routed by the guest network. Make sense? Okay. So, and I think I am on EduRoam here. Yeah, so I should be good. But wait a minute, how come we were able to get to that database here, even if I was on the guest network? How come I was able to get to it here? Yeah, so I'm not, from this browser, I'm not talking to the database. I'm talking to a web server. That web server, which is outside the network, is what's doing the talking to the database. And so here, I'm working on port 80. I'm talking to that thing on port 80, and the guest network, this will be just fine. The guest network, because the guest network routes port 80 traffic. Okay, so again, you're not going to follow along with me on this just now, because if we have too many simultaneous connections, we'll have a problem. But here's how we do it. I'm going to come to my data tab, get data, and now from database. Here's a bunch of databases that we can work with. Here's Oracle, here's DB2, here's MySQL, Postgres. I think most of these we talked about. But right here's the top one, SQL Server. I'll select that, and it's going to say, great, you got to tell me some information about how you want to connect. The server I want to connect to now is the same information that we used here. So data.sql.org. The database is user data. I'll say OK. And you know what? I connected here recently, and so oh, good. It's asking me again. Good. So how do you want to authenticate? Are you going to use your Windows credentials? Are you going to use a Microsoft account? Or are you going to ask the database to authenticate you? We'll ask the database to authenticate me. And this was VBA student. VBA student. And let me get the password. Going to apply these here. That sounds great. And we're going to try to connect. So now we are trying to connect from Excel directly to that database server. And if this goes well, here in just a moment, we'll have some other choices. Not that choice. Unable to connect. Let's edit that. Maybe I did something wrong. Oh yeah, no HTTP here. This is just the host name. There we go. So now we have successfully communicated with that server, and right now Excel is collecting the list of data that I have available to me. Remember, the database server is saying, hey, you've just authenticated. I know who you are. You're a VBA student. I'm going to build the list of things that you're allowed to see. And hopefully it'll come before too long. Should give me a pile of data to access. Lots of different tables I have access to here. Okay, so now it has given me the set of tables that we can work with. It turns out that in relational database management, there are two kinds of tables. There's a table called, well, there's two kinds of relations. There's a relation called a table, which is just where we're actually storing the data. There's also a relation called a view, which is like a saved query. It's like someone has said, you know what, take these two tables, join them together, restrict them, and that's another set of data that I can access. For some reason, I'm not exactly sure why, but these views are showing first. So red cat's what I'm after, but all of these are views. So I'm going to scroll down a little bit further till I find the other red cat data. And here now are the manufacturers. So here's the red cat manufacturer table. I'll select this. We should get a little preview. I may not even need the preview. It's just going to show the table. And now I'll say load. When I say load, it should open up a new, or make a new sheet. I hope it didn't just die. You should make a new sheet and bring that data then onto my workbook. And it is now not just, I've not just imported this data, this is now a database query. I could refresh this data, come up to my data tab, and there's a refresh button. I can just refresh this. So if the data has changed on the server, I'll get a new copy of it pulled here. And so at this point, we've just used the built-in tools to be able to pull data. We are using Excel now as a front end to the SQL Server database, but it's read-only. Only thing I can do is just see the data that's here. I can change it. Instead of, Palmer Way, I could change this to Palmer Drive. Wasn't there a golfer named Palmer? He does a lot of driving. That's what golfers do. And I changed it here, but it's not connected. That did not push that change back to the database. And so, and in fact, if I tried to make that change, the database engine would say no, because the VBA user does not have permission to change the data in the Red Cat customers. So this data is disconnected from the data that's there. But of course, we are here really to see how to do all this stuff with VBA. So let's go accomplish this same thing, but let's do it with VBA. All right, so I'm going to insert, come to my code, Alt F11. I'm going to insert a module. And I've given some code to get started. And now this part I want you to do along with me. So the problem with having simultaneous open connections is that as soon as we started to make the connection there, that connection actually stays open. It's maintaining a connection from Excel to the database server until that data comes in. And if we tried to all have simultaneous connections, that would be a problem. But what we're going to do in VBA is we're going to make it very quickly. We're going to make it happen quickly so that when we run the code, it'll make a connection, it'll get the data, and it'll close the connection. So we won't have to worry about having too many simultaneous connections. But I've given, it's actually on it's on next Monday's day, dbconnect.txt. Let's go ahead and open that. And you'll want to copy this sub-procedure in. So this has, kind of the bare bones that we need to be able to pull data back from a database. Now, a question here? Yeah, we're opening a brand new workbook, and we've inserted a module, a general module. So, say the question? So the question is, so we don't pull the data, so don't do this. Yeah, don't do that. Do that, tonight. Get some popcorn, go back, watch the video. If you want to. You may not want to. There's nothing in this class that would compel you to do that. It's not part of any project or anything. It's just kind of showing you that Excel can do that without VBA. It'd be pretty bad if you showed up, for a job interview and they said, "Hey, do you know anything about, pulling data from a database in Excel?" And you said, "Yeah, I can write a program to do that." And you show them this, and they go, "You could just go click, 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 and it's here." You go, "Oh yeah, I didn't know that." So I wanted you to see, there's tools kind of built in for part of what we're doing today. And of course, as we mentioned, when you're just using the Excel front end to access the database, it's read-only. And of course, where we're headed here is to be able to modify the data as well. So we'll see that too. Okay, now, we have worked with lots of different objects, lots of different kinds of objects since we've been, here in class? What are some of the objects that we've manipulated through VBA? Or the kinds of objects? Let's throw out an object that we've manipulated. String, actually variable, not an object. Worksheet is an object. The sheets collection is another object. It's a collection, so both, there's two there. Workbooks, ranges, charts, all these things are objects. Pivot tables, pivot caches, we've done all this stuff. We're going to need new objects for this. Now, the objects that it takes to interact with a database, all those other objects that we've worked with so far, they come with us out of the box. We open up Excel and we've got access to those objects. We might have to run some VBA to create those objects, like the pivot table or the pivot cache, but we have access to them without doing anything special. The objects that it takes to work with the database, they're not built into Excel. Now, turns out they're really easy to get access to, but this code requires that we have a reference to those object libraries. And that's what this first comment is here. The ActiveX data object database library. Here's how we made it, and I've shown you how to make the reference. By the way, once you've brought that reference into this workbook, the reference will follow the workbook. So if you save this workbook, take it to another machine and open it up again, the reference is still there, your code will be fine. But if you copy this example, as we've done, into a new workbook, you've got to tell it, hey, these objects, we got to know where to find these objects. Right now, if I try to run this code, let me just go ahead and run it. It's going to get to this part right here and say, I have no idea what you're talking about. What's this? Trying to make an ADO DB, I don't know what that is. And so we have to tell it, oh yeah, those objects exist, and there's a library that you can find them in. Here's how we do it. Tools, references. That'll bring up all the objects that we have available to us on this machine. And these objects will be different depending on what software is installed. So if you have installed software that makes part of its functionality available through the component object model, which is the way VBA accesses it, this stuff is here. What do I have in here? Do I have anything interesting here? It's apparently I've got something to do with Adobe Acrobat because I've got Acrobat Access Type Library. Oh, maybe it's, what else do I have here? Some more Adobe stuff. I've got Photoshop. I could actually automate something with Photoshop here. I'm not sure exactly what these do, but that's what these are here for. Now, some of them just come with Windows, and that's the one that we're looking for here. So I'm going to come down here to Microsoft. Here we go. Microsoft the Microsoft ActiveX Data Objects. Here they are. And I'm going to do this one, the 6.1 library. All these, I think any of these would work from 2.0 all the way up to 2.1, 2.5, 2.6, 7, 8. We skipped to 6. I don't know what happened to 3, 4, and 5, but apparently we wanted to go to 6. It's not enough to select it here. You've got to put the check mark. So you've got to make sure that's the reference, that's the library. It's a set of object definitions that we're going to now have access to. So I'll say OK. I've kind of declared these in a strange order. The order doesn't really matter, but I'm going to move this one up just so we can talk about it. So these two that I have showing here, these are the two objects that we need to be able to work with data in a database. The first one, the connection object, is what allows us to talk to the server. Right? There's a server out there somewhere. It's listening on port 1433. It's at a particular host name. I've got an object that just knows how to talk to a server. And there's different kinds of things I can do with that server. One of the things I could do on that server is I could tell it to update data. I could say, server, update this data. Server, delete this data. Server, insert this data. And those three things, update, insert, delete, are fundamentally different from what we're doing here, which is to say, give me some data. I'm asking for some data. And if I'm going to ask for data, it takes another object. And that object is a record set. And so the record set object knows how to say, oh, you've got a set of records here. I'm going to have the methods and properties that it takes to be able to deal with a set of records. And so we need to be able to bring data back. I need both of those two things. The connection, which gets me to the server, and a separate object called a record set that lets me deal with the records that I'm after. I've got a couple of other strings then defined here. CS just short for connection string. That's the information that we need to tell the connection object how to connect to the server. And then SQL is just going to be the SQL statement that I'm going to execute. So here I'm getting my connection string configured. So CS equals, this is just a string. And so this tells us just the same information that I had to do as I was as I did that example where I was pulling the data. Number one, I had to tell it, I'm bringing data from SQL Server. This string says the driver that we're using is the SQL Server driver. We'll be talking to SQL Server. Number two, it's kind of out of order here, but I also had to say, what server am I talking to? Well, I'm talking to the server at the host, data.websql. Incidentally, it's also on port 1433. I could specify that here. Maybe after I've got it working, I'll go ahead and specify the port, and we'll see that it still works. And I got to say which database. I specified all these things. Now I'm ready to open the connection. So the connection object, I call the open method, and I'm giving it the connection string that I just defined here. Right? I'm giving it the parameters that it needs to know how to talk to the server, and I'm also giving it my username and password. So this is going to get me, it should get me connected. In fact, I'm going to, don't all of you do this. I'm going to do what I just told you we weren't going to do. I'm going to hold the connection open. I'm going to stop this right here, and if I can get to that without error, then I've successfully connected to that database. It's amazing how fast that happened. How long did it take me to actually get connected through the Excel? It seemed like it took forever, but that quickly, I'm connected to it. I'll go ahead and just finish this off. Okay, so far so good. Oh, you know what? While we're there, let me go ahead and try this. I'll specify the port, 1433, and I think that's the way we specify the port. Yeah, so it still connects just fine. If, on the other hand, I try 1423, then I should have something similar that happened with our browser, and that is I'm running this. I haven't hit the breakpoint yet because it sent the request. It's now waiting for that server to respond. That server's not going to respond because there's no server listening on that port. Okay. So maybe we'll sit there and wait for it to time out so you can kind of see what happens. Yeah, so here it goes. It says server does not exist or access denied. Which of those two is the truth? Yes, server does not exist. Typically, if it's access denied, you can tell the difference because if it's access denied, it comes back like that. Yeah, I talked to the server, it said no. But when you're sitting here waiting and waiting and waiting, and it says one of these two things happened, it couldn't talk to that server. There was no server at the address I was talking, the address and port I was talking to. By the way, in 2001, there was, it was a wonderful day. The internet was closed for one day in 2001. Did you know this? Probably weren't even using the internet. How old were you in 2001? Oh, 14, so you might have been on the internet. 7, you probably weren't doing much on the internet at age 7. There was a vulnerability in Microsoft SQL Server, and someone wrote a worm to take advantage of that vulnerability. It was called the Slammer worm. It was really simple. All it did was it tried to talk to a SQL server on a port. It said, just port 1433 at this randomly chosen IP address, and see if there's a SQL server there. If so, run this code that would infect it. And what was the result of the infection? That SQL server would start trying to talk to other SQL servers. That was it. It would randomly guess an IP address, talk to it on port 1433. Oh, you're there, I'll infect you, and you can start helping us talk to other SQL servers and infecting them. There was nothing, it wasn't trying to steal data. It wasn't trying to damage data. I'm not sure why the guy wrote it or what he's hoping to accomplish, but within 45 minutes, it had completely turned off the internet. There was so much port 1433 traffic going everywhere that nothing else could get through. What happened? Well, if you're an ISP, you start getting an internet service provider. People are paying you to give them connection to the internet. All of a sudden, people are going, hey, I can't log into my email. What's going on? You get flooded with all these requests. You look at your data and go, oh my gosh, 99% of our traffic is for port 1433. What's port 1433? Who cares? Get rid of it. And so just the same way that our guest network doesn't route port 1433 traffic, it doesn't route almost any traffic, internet service providers around the world said, stop routing port 1433 traffic. If we get a request for 1433, dump it off and forget it. It took about 24 hours for enough ISPs to do that we could successfully route traffic on the internet again. For about a decade after that, you could not successfully talk to a SQL Server on port 1433 because there were still a bunch of network or internet service providers that refused to route port 1433 traffic. So, your network could be routing it, the other end could be routing it, but if it happened to get routed through an ISP that said, yeah, forget 1433, you just couldn't connect. I'm not sure that was really useful, but in the old days of the internet. I'll go ahead and leave the port on there, but it's the default, and so we don't really have to leave it there. Okay, so we saw that by the time we hit this breakpoint, we're successfully connected. We've reached out, talked to the database has said, yeah, great, what do you want me to do? So now we're ready to specify the information that we want. So just like I said, I wanted the list of manufacturers, so here is select all columns from the manufacturer table. I'm specifying that as a string. This is nothing magic, it's just a collection of characters. And now I'm ready to call the open method of the record set object. The record set object says, give me a connection and tell me which records you want. I'll manage the records for you. And so we have to give it these two values. I got to tell it which records I want. That's the SQL statement, the structured query language statement. And I tell it which connection to operate on. And it says, great, I'm going to fetch those records and then we'll be able to manage them for you. Next thing we're doing here is we are just printing a single value. Now, this is going to bring back like 50 records and a dozen or so columns, maybe 8 columns, I don't know. I'm only asking to print one field. So I'm printing, look at the record set. Record set has a collection called fields, and I'm asking to print the number 1 field. Now, as it turns out, you might think a record set's the whole set of records. It's not. A record set is the object that knows how to handle a set of records, but it only has access to one record at a time. And that's great news, because I could write a query that brings back 10 million records. And if this object's going to try to hold all 10 million of those simultaneously, I got to have enough memory to hold all 10 million records. I probably don't. And so the record set object is designed to say, we got that, you've told me the records you want, we're going to deal with them one at a time. That's super. And so this should actually just print off one of my manufacturers. Let's see what it does. I'll take off the breakpoint, and now you can run this with me. But it should run that, and it's bringing back one of the manufacturers. Is that one of my manufacturers? Let me go back here and take a look. Remote query. Yeah, it's the first one that comes up, Ratty Footwear. I think these are real manufacturers, even though the company, the Red Hat or Red Cat Shoes is fictitious. I think these are real manufacturers. Anyone heard of this company before? Ratty Footwear? Baby Fat, that one? I don't know. Keds, that's one that I grew up with. What else we got here? We got 2 Keds. That's a problem. Oh, there's Reebok. There's one that sounds familiar. Adidas. Okay. But I'm only getting one because I only have access to one at a time. So let's go ahead and get the next one. So I'm going to print the first one. I'll print the second one. And in between, I've got to tell it to move to the next record. So the record set object, rs, has a method called moveNext. I just say moveNext. And now it should print the first one and the second one. Where am I headed? What's the next structure I'm about to build here? Yeah, loop. You can feel the loop coming, can't you? So instead of printing this again, let's just put this in a loop. So loop do. I got to give myself some way to get out of the loop. This loop would end with an error when I tried to move past the end of the data. But let me get out of it at a certain point. I'll do this. I will do until rs dot, it has a property called EOF. Stands for end of file. It is a logical, it's a Boolean property, true or false. And end of file is false until we've tried to read, not until we've read the last record, until we try to read the record after the last record. It's when I try to access a record that doesn't exist that it says, aha, we've reached the end of the file. So it starts off as false. So do until, and remember the until is going to let me out when this equals true. Right now it's false. So do until EOF, right now it's false, and so we execute. We're going to print the first record. We move to the next record, back to the top. We'll print the second record. We move to the third record. We come back to the top. We print the third record. We move to the fourth record. Ultimately, we move to the very last record. When I read that last record, is EOF true or false? EOF is false. I've read the last record. EOF is still false. So I move next. That takes me to the last record. I come up here. Am I at the end of the file? No. So EOF is still false. I then print the last record. And now I try to move past the last record. And this is when it goes to true. I mean, it says move next. It doesn't go to a next record. Instead, it sets the EOF to true. So I hit the loop. I come back up here. EOF is true. And then we stop the loop. So now I should print the names of all of those manufacturers. There they are. Got to be Nike in here somewhere. Ah, there's Nike. Cadillac footwear. That's awesome. Okay. Question. Oh, okay, here's the question. The question is, hey, you know, all this work to bring back all these columns. You're bringing back the manufacturer ID, the manufacturer name, the city, state, zip, his URL. Why do that? And the answer is, I'm going to show more than I'm showing now. I'm just, you know, we're getting there. So, but you're right. If that's all I was after was the names, I would probably change this to say select manufacturer name, and that way it's not bringing back extra data that we're not using. It would be a lot more. It would be a lot more efficient. Yeah, we're headed there. Yeah, we are going to duplicate the feature that we saw, you know, with just through the Excel interface, and then we'll move on to do some more advanced stuff. Okay, manufacturer, good. So now let's go ahead and instead of putting this to the immediate window, let's put it to the worksheet. In fact, if you remember what the tool from the interface did, was step one, it created a new worksheet. So let's go ahead and do that. Let's go ahead and maybe as soon as we've opened the connection, right after we've opened the record set, that's fine. We're going to add a sheet. That way, if we fail somewhere in here with the connection, it won't add a sheet that we're not going to use. So I'm just going to say worksheets.add. Maybe I'll say this workbook. If I didn't say this workbook, which workbook would it choose? Whichever one was active. So if I had multiple active workbooks, but this way it'll be in the workbook that contains the code. All right. So now we're going to need something to kind of keep track of where we are. So you come up here, and I'm going to dim R as a long integer. Let me dim, well, you need it in a minute. Let me dim C as an integer. We got a row and a column. Now let's do this. Let me set R equal to 2. After we move next, I'm going to increment this. R equals R plus 1. And instead of printing, let's just say cells, row number R, column number, let's put this in column number 2 for now, dot value equals the value that we're pulling off of the field. In fact, while we're at it, why don't we pull 2 in? So we're going to pull in on our row and column. Let's also, in column 1, let's read field number 0. Yep, it turns out the fields collection is 0-based. So that's why when we asked for number 1, we got our manufacturer name instead of our manufacturer ID, because this is field number 0. So now this should, as we go, we're incrementing, we're getting to a new row. This should dump off those first 2 columns onto the worksheet. Let me see if it does. Yeah. So it's giving me a new sheet. I've now got sheet 3 here. And I've got those 2. Now, I'm not getting the name because so far all I've dealt with is the value. So why don't we start off by putting the names right across on row 1, the names of all of our columns. So even before I come here to start working with the data, let's make another loop. For C equals 1, 2, however many fields there are in the record set. So rs.fields.count. Next. what am I going to do? I'm going to do really something similar to where I was putting this value out. But now I'm going to be writing at row number 1, column number C. So I'm going to go right across that first column, or that first row. The first time through, my column is going to be 1, so I'm going to look at row number 1, column number 1. I'll put something there. Then I'm going to go to the next column over, and so forth. But instead of writing the value, I want to write the name. So the field has a property called name. It's the name of the field. And so now, let me go ahead and run this. It should bring that data back. Oh. Yeah, instead of field number 0, that's what I got field number 0 a bunch of times. Manufacturer ID, all these times. So instead of field number 0, it should be field number C. Now, remember, C is going to start at 1, and I have to start at 0, so C minus 1. And so now I've gotten the names of the fields. There's the manufacturer name, address 1, address 2, city, state, postal code, phone, fax, contact URL. Okay. Well, now we're ready to write the data out too. Whew. But instead of just duplicating this and having field 1, field 2, field 3, field 4, let's do it with a loop. So I'm going to copy this same loop, and I'm going to bring it right back over these 2 lines. I'll just get rid of those, paste my loop in. So now I'm going to go for each column, but instead of writing to row number 1, I'm going to write where? Row number R. And instead of writing the name of the column, I'm going to write the value of the column. So now this should give me a sheet that has the data. It looks pretty good. Questions? I think I would like to make it a table, just the way that import happens. Trouble is, I can never remember how to do that. So I'm going to record myself, and the code's not that bad. You can probably just type what I record here. So let me go ahead and record macro 2. That's a great name. I'm just going to say insert table. And that default is fine. So that's going to build it into the table. That looks pretty good. I'll stop recording. And we'll go look at that code. It really is just one line. I just don't know it well enough to type it. We'll have to modify it just a bit. Okay, so after we've looped through our data, after we've closed our record set, after we've closed our connection, I'm ready to actually build this into a table. So active sheet, that's great because I just made the sheet. List objects, we're adding a list object. It's going to be an Excel source range. That's good. This is a problem. This now is a fixed range. So instead, I want us to figure out the range. That'll be easy. Cells number 1, wait a minute. Normally, when I say cells, I give it a row and a column. What cell is it talking about if I just say cell number 1? That's A1. What's cell number 2? B1. Cell number 3, it goes right across the row first. It goes across like 16,000, and then it kind of comes back to the next row. But upper left-hand corner, that's an easy way to do it. Dot, how do I get to the whole set of contiguous data? Oh, you know what? Let's do this. Here's one I don't think we've seen before. I'm going to say my active sheet. I was headed in the direction of current region. But it's possible that even though it's kind of difficult to get in my database a whole row where every column's blank, or every value's blank on that row, I might not be getting the whole row. I could be bringing back just a couple of columns, and it'd be pretty easy to get 2 blank rows that way. If I use current region, it's going to stop there. So instead, I'm going to say active sheet dot. I think I'm going to say active sheet dot. Let's see if it gives me some help here. ACTIVE sheet dot, come on, help. It's called used range. So what the used range is on your sheet, it is the smallest rectangle that contains all the data. So even if I've got a blank row in here, this will still pick up that whole set of data. And here, yes, I think means it's got column headers. This is going to give it a name, table 2. I don't think I need to give it a name. I think whatever name it defaults to will be fine. So I'm going to delete off the .name equals. But now that I'm not doing anything with this list object that gets returned, I no longer need the parentheses either. So I'm going to get rid of those parentheses. And that should be the line that will make that into we'll actually build it into a table. Now the one last step is to auto-fit all of the columns. So I'll do that with the use range again. My next statement, ActiveSheet.usedRange. Dot entire column dot autofit. So now when it creates the sheet, it'll create the sheet, bring the data in, make it into a table, auto-fit the columns, and it should be pretty close to what we had from the interface example. I'll run that again, and there we have it. Kind of properly sized, it's a table, happens pretty quick. I like it. Questions? Here's a problem. Look at what's the problem with zip code? Yeah, it has to do with whether it's a string or a number, but I don't really care if it's a string or a number as long as it's all there. But what's the problem here? If it has a leading 0, that's a problem. And so because if I put a number into an Excel cell with a leading 0, it goes, aha, I recognize that. That's a number. I know numbers when I see them. Yeah, what do you need this leading 0 for? Forget it. Throws away the leading 0 and just stores that as a number. And that's going to be a problem. Oof. Unless I'm very much mistaken, when I come back here to sheet 2, the leading zeros have been preserved. Oh, these guys at Microsoft have beaten me. Here I thought we had it the same, and they're handling this 0 correctly. So it turns out, so every field in my fields collection on my record set, it has a name, it has a value, and it has a type. We can ask what the type is, and we can look at it and go, oh, is this a type that's string data? If so, let's format this column as text so we don't lose those values. Let me just print off. We'll do it up here in the heading. Let me just print off the types of all of these. Debug.print. Instead of the field's name, we're still writing the name to the worksheet, but I'm going to print the field's type. I'm going to put a comma after it so it will print them all on the same. No, I won't. I'll leave that off. Oops. Okay. Let me go ahead and clear my immediate window. Run this again. It should still make a sheet, bring the data in. But now it says, great, field number 1 is type 3. That's my number. Field number 2, manufacturer name, is type 202. So is field number 3, 4, 5, and 6. So with a little bit of Googling, there's probably named constants for these. And we could find out what they all are and decide, should we treat this as a text or should we treat it as a number? This gets a little bit ugly. And we've only got like 8 minutes to go. It's not enough to do that. But I'm going to show you another approach that will handle that. So at this point, what we've seen, and it was important for us to see, here's how we manipulate one record at a time. It is often the case that you have to do that. It's not always that you're going to pull this data off and dump it off to a worksheet. You might want to pull the results back and just look at it, have your code look at it, find the ones that you're interested in, and do something with it without ever showing the user the data. So that's why we want to see how to work one at a time here. Also, because there may not be room to put all the data into Excel. It could be that you've got to work with a record set that's got 2 million results. By the way, is 2 million records a lot of data in the world of database? It's, it's not a huge amount of data, but it's a significant amount of data. But it's not like, oh my gosh, you're dealing with 2 million rows. No one says that. Well, someone might say that, but data folks don't say that. And so it might not be an option to pull the data back and dump it into the worksheet. So, but let's take I'm going to go ahead and copy this. I'm going to show you a shortcut to what we're actually trying to accomplish here. Yes, go ahead. When you're starting to read, is there a way to ask how many rows are there? So, that's a good question. So the question is it possible when I start reading to know there's going to be 500 rows in this set? And to answer that, yes and no. The first way that you could do it is that you could restrict this. Your query could say only bring back the top 20 rows. So you could say, I only want to bring back a certain number of rows. Another approach is, depending on the configuration of the record set, you can tell this record set, I want to know how many rows there are. And I say that about record sets in general. I'm not sure what the methods are here for these objects, but you can typically, with record sets, you can say, on this record set, I want to know how many rows there are. That's expensive, because the record set has to know how many rows there are. So the question is, does the database have a header for that information? And the answer is, the database might easily know how many rows are in the table, but this isn't a table we're asking for. This is a query. And so it doesn't just automatically know the results of this query. It doesn't know how many there are. In fact, what will happen is that this, depending on what I've done, if I haven't asked this query to be sorted, I just say, give me the records. The database engine will start sending the records back before the database engine knows how many records there are. Right? It's going through, if it's a complex query, it could be going through, okay, I found a record, found a record, found a record, found a record. And as soon as it's finding these records, it starts sending them back to the record set. And the database, and so the database engine is still working on the query, but it's already started to give the data back. So in that case, we're saying nobody knows how many records there are. We can't possibly know. So if we tell it we got to know how many records there are, first thing that has to happen is the whole query has to execute first before I start getting records back. And that record set has to be able to figure out how many there are. So it's typically expensive. So generally, you say, I want to deal with these record sets without knowing how many records there are. You might have code in here that says, once I reach 500, stop. I don't want to see more than 500 rows of data here. And if that's the case, you'd probably put in your query here, select, and every database, and it's different in different versions of SQL depending on the database manufacturer. But everyone has a way to limit the number of records. In SQL Server, it is, you put right here, like top 20 before the list. That says how many records do you want. And so if I run this, 20 results. And there they are on rows 20 through, or row 2 through 21. Okay. So let me go ahead and I'm going to back off that top 20. And I'm going to copy this sub-procedure. And paste it. Got a copy. I'll call this one, just call it DB2. All right. So interesting. Did I not delete it down below? Thank you. All right, now here, everything that happens, from the time that I open the connection set till the time that I close the connection set, this is going to be exactly the same. A worksheet add is going to be the same as well. But now, instead of all of this, you know what? I'm going to leave the part that puts the header in. So here's the loop that deals with the data. I'm going to get rid of the loop that deals with the data. Delete. And instead, I'm going to do this. Cells Ooh, let me do this. I'm gonna change it to a specific cell, but first I'm gonna start with active cell because I need a little help. And if I say cells 1, it won't give it to me. Well, maybe if I say range A1, it will. Range A1 dot, oh good. So I'm gonna say, not starting with A1, A1 has my header, I want A2, column A, row 2. Dot, and it has a method, look at this, called copy from record set. So even though the record set object itself is not native to Excel, the range object says, you know what, you might have a record set object, and if so, you might want me to just copy the data straight from the record set. So I'll say copy from record set. I need to tell it the record set I want to copy the data from, RS. Oh, here's max rows and max columns, which I could specify right here on this method to tell it how many to stop at and so forth. So now I should be able to run this, and it should give me a new sheet, bring in the headers, bring in the data, but copy from record set is smart enough to figure out the information about if this is text, formatted as text, even though it's a number. So that's kind of a slick method. And by the way, copy from record set is dramatically faster than working with it record at a time. So if you've got a big record set to bring in, say you've got 50,000 records, that's not big, but if you've got 50,000 records to bring in, to do it with the loops, it might take, depending on your configuration, it might take 20 to 30 seconds, or 10 to 30 seconds to do it. And it might take 3 or 4 seconds to do it with copy from record set. So it's just, it's wired to do it a lot faster. Questions? So far with VBA, all we've done is replicated what we could have done without it, right? We just brought in the data. When we get together on Monday, we're going to see how do we now change the data? How can we update data from Excel and push it back to the database management system? All right, folks, thanks for coming. We will see you on Monday. Class dismissed.